Hello everyone, I am Dr. Pavitra Singh. Today I will discuss about the projection of solids in this video. So first I will try to solve problem first. A square prism of side 50 mm and height of 70 mm has its base on the horizontal plane such that its vertical faces are equally inclined to the vertical plane. So actually you can see this is a three-dimensional figure of this square prism. So prism is actually is a 3D object which is having the cross-sectional area same throughout the length of this prism. So there is no change in the cross-sectional area. So the top surface and bottom surface is same, but in case of pyramid you can see the cross-sectional area of pyramid will be decreased continuously and it will be 0 on the top. Okay, so here it is a square plane. Suppose it is having 4 sides, then this will be square plane. If it is having 5 sides, then it will be pentagonal prism. If it is having 6 sides, then it will be hexagonal prism. Okay, so now I will solve this problem. So this three-dimensional object is kept on the horizontal plane simply in the vertical direction. So its axis is perpendicular to the horizontal plane, and the surface of this prism, this surface and this surface is making equal angle with the vertical plane. So actually this surface is making this angle 45 degree. Okay, similarly this surface is also making this angle 45 degree. So this is kept on the horizontal plane in such a way that its one surface in the red color is making 45 degree with the vertical plane, and this will be projected below the xy line. Similarly this surface is also making 45 degree angle with the vertical plane. So when we will see this from the front, so we can see this surface, okay, and this surface only. So this is actually projected on the xy line. So this surface is this one, okay, and this surface is this one. So we can see this rectangular shape and this rectangular shape here in the front view. Okay, when we will see from the top, okay, so we can see this surface. Okay, so this will be this one, this red surface, okay, this red surface, this blue surface and this blue surface. So this will be the top view and top surface can be seen from the top. Okay, suppose this is point A1, sorry, A dash, this is B dash, this is point C dash and this is point D dash. So you can see this will be A, B, C and D. Similarly this is the base surface. So this is base. So suppose this is point P, this is point Q, okay, this is point R and S will be in the back side. Okay, so when you see this from top, you can see only this surface, means A, B, C, D will be visible and the bottom surface will be in the back side of this top surface. So point A dash and P dash will be on this point. So here point A and P will be on this point. Similarly point B dash and Q dash will be projected on this point. So this will be B and Q. C dash and R dash will be projected on this point. So this will be C and R. Okay, C and R. Similarly, D dash and S dash will be here. So this will be D and S. So this is the top view and this is the front view. So finally we will draw in the drawing sheet without any color. So we will draw XY line. This will be point A and P. This will be point B and Q, point C and R, D and S. Okay, and here this will be A dash, B dash, C dash and D dash. Okay, so D point will be on this location. Similarly, this will be P dash, Q dash, R dash and S dash. Okay, so this is the front view and this is the top view of this problem. So in the second problem, you can see a square prism has its base on the ground and its a side inclined at 30 degree to the vertical plane. The axis is 50 mm in front of vertical plane. Draw the projections taking a side of the base 30 mm long and axis of 75 mm long. So actually this is 50 mm. Okay, axis is 50 mm. Clear? So now only one difference is there between problem first and second. In case of the first problem, the side of this prism is equally inclined with the vertical plane. So actually this angle is 45, means this is also 45 degree. But in the second problem, this side is inclined 30 degree with the vertical plane. Okay, so this is inclined 30 degree with the vertical plane. So suppose this is 30 degree, then this is 90 degree, then this will be 60 degree. So this line is this line is making 60 degree angle. So in the first case both angles were same, 45 and 45, but in the second case this is 60 degree and this is 30 degree. So we can see this surface from this side and this side. So this surface will be projected equal to this and this surface will be projected equal to this. So you can see this blue color is having larger distance than this red color. So this surface is seen smaller than this surface in the front view. Okay, but in this case both are equal. So this is due to the inclination of this line 30 degree with the vertical plane. So this is larger and this is a smaller line. Okay, so this is the front view and this is the top view of this problem. So this is the same problem like in the first problem, but only difference of the inclination. So this is inclined 30 degree and this is inclined 45 degree. Okay, that's why this surface is larger than this surface. Okay, so now we will try to solve third problem. So you can see draw the projections of a pentagonal prism as of base 30 mm and axis 50 mm long, having one of its base as perpendicular to the vertical plane. So now we need to draw its projections. So actually this is a pentagonal prism. So as per the given condition, it is resting on the horizontal plane. So its axis will be perpendicular to the horizontal plane, and this this solid will be parallel to the vertical plane. So actually this pentagonal prism is kept on the horizontal plane like this. Okay, when you see from the top, this surface will be projected below the xy line. So this will be actually pentagonal shape, and this will be its height. Okay, so here you can see, we can see the complete surface of this pentagon from top. So we will draw first the top view. So actually this is the pentagonal shape, means surface. So this is line AB, BC, CD, DE and EA. So we have taken this line EA equal to 30 mm, 30 mm, 30 mm, 30 mm, 30 mm, and this angle will be 108 degree. Okay, so we have constructed this pentagonal plane here, because when we will see from top, we can see only the one surface, and another surface of its bottom will be in the back side of this top surface. So the bottom surface is covered by the top surface. So now we will draw the vertical lines from the top view. So vertical line is drawn from point A, okay, from point B, from point C, from point D, from point E. Okay, suppose this is the base of this pentagonal plane. Okay, and the numbering for the base is P, Q, R, S, T. Okay, so this will be actually point P projected vertically on this xy line. So this will be point P dash, and this will be Q dash, and from this point this will be R dash, this will be S dash, and this will be T dash. Okay, so point P and T will be on this location. Point Q and S will be on this location, and point R will be on this location. So this is actually front view of this bottom surface, P dash, T dash, Q dash, S dash, R dash. Similarly, we will draw another line parallel to this xy line, maintaining the distance 50 mm, because height of this prism is 50 mm. So we have drawn this line, okay, above 50 mm from this bottom surface. So now we will project vertical line from point A. Okay, so we will measure this line 50 mm. So this will be E dash. Again, vertical projection from point B. So this will be actually point B dash. From C, this will be C dash. From D, this will be D dash. From point E, this will be E dash. So this is actually the front view of this top surface, and we can see this surface and this surface from the front. So this is this surface when we are looking this from front, and this surface will be this one. Okay, so we can see only two surfaces from the front side, and remaining these three surfaces will be in the back side. So actually this is the front view of this prism. Okay, now we will try to solve another problem. So a cylindrical prism of 60 mm diameter and axis of 70 mm has its axis parallel to the horizontal plane, and it is inclined 30 degree with the vertical plane. So we need to draw its projection. So actually a cylindrical prism, suppose this is a water glass. So actually this is a cylindrical shape, okay, and it is lying on the horizontal plane like this. So you can see from front, so you can see this cylindrical prism. So this circle will be seen from the front. If you are looking from top, so you can see only rectangle will be there. Okay, so now you can see the circular shape will be seen from the front view, and from top we can see this rectangular shape. So actually we will draw first XY line, then we will project the front view, because we can see a circular plane or surface from front. So we have taken one center point, and we will draw this circle of diameter 60 mm. Now we will locate 8 points on this circle. Then we will draw vertical lines from point E dash, from point B dash, from point C dash, from point D dash, from point E dash. Okay, and we will draw one horizontal line and another horizontal line 70 mm apart from this line. So actually we will draw projection of one surface, means this is bottom surface, and another is top surface, because this cylinder have bottom surface and this top surface. Okay, so we have selected this height equal to 70 mm, and this is one surface and this is another surface. So for the first surface we have taken P, Q, R, S, T, U, V, W numbers, means points, and similarly for the other surface. So actually we will focus first on the one surface. So first we will draw this line which is parallel to vertical plane. Okay, so here you can see this is point A, B, A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash for the one surface, and P dash, Q dash, R dash, S dash, T dash, U dash, V dash, W dash for another surface. Okay, so numbering is there for bottom and top surface. So now we will pick one surface and we will draw one line which is parallel to XY line. So here you can see when we projected vertical line from point A dash or P dash, suppose we are drawing first this surface, so we will draw vertical line from point P dash, so we will get this point P, vertical line from Q dash, this point Q, vertical line from point R, this will be R point, from S this will be S point, from T dash this will be T point, from U dash this will be U point, and from V dash this will be U point, from W this will be W. So point Q and W will be on this location, R and V will be on this location, S and U will be on this location, and T will be here. Okay, so this is the top view of the bottom surface. Similarly, when we will see from top, so we will draw vertical line from point A dash, so we will get this point A, from B dash we will get this point B, from C we will get this point C, from D we will get point this D, and from E we will get this point E, then from F dash, from G dash, from H dash. So we will get this line for the top surface. So top surface will be this, sorry, bottom surface will be this, and top surface will be this, and this will be the circumference, means periphery of the cylinder. So now this is the simple projection of this cylindrical prism which is lying on the horizontal plane. Okay, now we will try to solve the second condition. So in the second condition, it is given that this is inclined 30° with the vertical plane. So now we will draw one line, this line. So actually this is center line of this cylindrical shape. So we have taken or drawn this line which is inclined 30° with the XY line, because it is inclined 30° to the vertical plane. So actually this is the center point of this cylindrical plane. So we have drawn this line here which is inclined 30°. Now we will mark all these points here on this line and these points on this line, and this is equal to 70. So we have reconstructed this figure here which is inclined 30° with the vertical plane. Now we will draw vertical projection. So actually first we have to consider one surface. Suppose we are trying to draw the projection of this surface. So first we will draw this surface only, then we will try to this surface. Okay, so we have drawn vertical lines from point point A and from B, from point C, from point D, from point E, from point F, from point G, from point H. Okay, so we have drawn vertical lines from all points A to H. Okay, and now we will draw horizontal lines from point A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash. Okay, so the intersection of these horizontal lines and vertical lines will give you 8 points, and we will connect all these points, so we will get this surface. Okay, so this is actually top surface of this circular prism. Okay, so this is actually cylindrical prism and its top surface is seen like this. Okay, now we will try to draw this surface in the front view. So we will draw vertical line from point P, horizontal line from P dash, so we will get this point P1. Similarly, vertical line from point Q, horizontal from Q dash, so this will be point Q1 dash. Vertical line from R, horizontal line from R dash, so you will get this R1. Vertical line from point S, horizontal line from S dash, so we will get this surface actually. So you can see when we are looking this from this side, we can see only P, Q, R, W and V point clearly, and the remaining these points will be in the back side. So we will project these points in the dotted lines. Okay, so now we will connect R1 dash to V1 dash, so we will get this surface. Okay, and we have already completed this surface, and we will connect now this line and this line. So this is actually the final projection of this cylindrical prism, which is inclined 30° with the vertical plane. Now we will solve this problem. So actually in this problem you can see a hexagonal prism of base 40 mm side and 70 mm long has a rectangular face on the horizontal plane, and its axis makes an angle of 60° with the vertical plane. Draw its projections. So actually this hexagonal prism is lying on the horizontal plane, and its one surface is touching this horizontal plane. Okay, means it is parallel to this horizontal plane. So now you can see, because it is lying on the horizontal plane and its axis is perpendicular to the vertical plane, means you can see this from the front complete hexagonal surface. So this is one hexagonal lamina. So we are looking this top surface, and the bottom surface will be behind of this front surface. Okay, so first we will try to draw this hexagonal surface. So suppose this line is lying on the horizontal plane, or this line is parallel to this horizontal plane, and this hexagonal plane is having its axis which is perpendicular to the vertical plane. That's why we can see the top view as a rectangle PADS. Okay, so when we will see this from the top, so we can see this surface, this surface, and this surface, and this surface, this surface, and this surface will be in the back side. That's why we will draw this surface. So this is the actually this surface, this one. Okay, and this surface will be this one. Okay, and this surface will be this one. So these three surfaces will be visible when we will see this from top. Okay, so this is the top view and this is front view of this hexagonal prism which is resting on the horizontal plane. Again we will incline it with 60-degree angle to the vertical plane. So in the second condition we will redraw this top view at an inclination of 60-degree angle. So this is actually center line of this, means axis of this hexagonal plane. So this is actually 60-degree. Then we will redraw this figure here. All the dimensions are same, only it is inclined at 60-degree. Okay, so we have redrawn this figure here. Now we will draw vertical projections from point P, Q, R, S, T, U. So we will get this hexagon. When we will draw projections from this surface, means vertical projections, so we will get this hexagonal shape. Okay, so first we will try to draw projections from this surface. So vertical line from point A and horizontal line from point A dash will give you point A1. Okay, horizontal line from point B, vertical line from point B dash, so this will give you B1 dash. Similarly, vertical line from point C and horizontal line from point C dash, so we will get this point C1 dash. Similarly, horizontal line from D dash and vertical line from D, we will get this D1 dash. Horizontal line from E dash, vertical line from E1 dash, so we will get this point. Similarly, we will get this point, and now we are having 6 points on this in this front view. So we will connect all these 6 points, A1 to B1 dash, B1 to C1 dash, C1 to D1 dash, D1 to E1 dash, E1 to F1 dash, F1 to A1 dash. Okay, so we will connect all these points, so we will get this final view of this surface. Similarly, we will draw vertical projections from each and every point for the bottom surface, so we will get this hexagonal surface. Okay, now we will connect Q1 dash to C1 dash and U1 dash to E1 dash. So this is the final front view of this inclined hexagonal prism of 40 mm side. Okay, so this is the fourth problem. Sorry, yes, this is the fourth problem. Okay, now I will try to solve this last and fifth problem. Okay, so actually this is the fifth problem. So a right regular pentagonal pyramid of base 30 mm and height of 45 mm has its base parallel to the vertical plane with one of its base as on the horizontal plane. So actually this pyramid is parallel to the horizontal plane, means its axis is parallel to horizontal plane. That's why we can see complete projection of its 5 sides from the top. If we are looking it from the top side, so we can see only 2 surfaces and remaining 3 surfaces will be in the back side. So actually this is the center point, center line of this pyramid. Okay, and as per the given condition, this is parallel to the horizontal plane, and its base or bottom surface is parallel to the vertical plane. So we can see the complete pentagon from the front side. Okay, so we will draw one xy line E dash D dash equal to 30 mm. Okay, and this line, so this angle will be 108 degree, this angle will be 108 degree. Then we will construct this pentagonal surface or lamina. Okay, so we have drawn one pentagon of side 30 mm and this is the center point. Then we will connect this point to this point, D dash to O dash, C dash to O dash, D dash to O dash, A dash to O dash. So actually this is one surface from the side view when we will see from front. So this will be one surface, this will be second, third, fourth, fifth. Okay, so when we will see this from front, we can see only 2 surfaces in the green color and in the blue color. So this will be projected like this. Okay, and this surface will be projected like this, and this surface means this surface and this surface and this surface will be in the back side of these 2 surfaces. Okay, so this is actually top view and this is front view of this pentagonal prism. So this was the problem from the pentagon. Okay, so now we will meet in the next video. Thanks for watching this video. All the best.